Hi, I'm Sijin Chen from Fudan University. I'd like to present our paper, End-to-End 3D Dance Captioning with Vote2Cap DETR. Paper and codes can be found through the QR codes below. 3D dance captioning is a challenging task that requires a model to accurately localize all objects of interest from a cluttered 3D scene represented by sparse point clouds, and generate informative and object-centric descriptions for each instance. Previous works for 3D dance captioning all adopt the detect then describe pipeline. This pipeline first generates a set of object proposals, then decodes each object to a caption with an explicit reasoning procedure. So these methods have achieved remarkable performance. The detect then describe pipeline suffers from the following issues. Because of the serial and explicit reasoning, the captioning performance highly depends on the object detection performance, which limits the mutual promotion of detection and captioning. The heavy reliance on handcrafted components introduced additional hyperparameters such as ready in 3D operators, proposal neighbors, and non-maximum suppression for post-processing, leading to a suboptimal performance given the sparse object surface and cluttered object distributions among different indoor scenes. This inspires us to design a one-stage 3D dance captioning system. Specifically, we adopt a single-stage transformer-based architecture and decode object queries to box estimations and captions in parallel. Our proposed Vote2Cap DETR is a full transformer encoder-decoder architecture for one-stage 3D dance captioning. We first tokenize the input point clouds to point tokens and extract features with a scene encoder. Then, we generate vote queries based on the encoded feature. Unlike traditional detect then describe pipelines, we directly feed the decoder's output into the localization head and caption head in parallel. By casting 3D dance captioning as a set-to-set problem, each target instance and its language annotation is matched with a query in a one-to-one correspondence manner, enabling a more discriminative feature representation for proposals to identify each distinctive object in a 3D scene. Though 3DETR has achieved initial success in 3D object detection, it suffers from certain limitations. 3DETR proposed box estimations around the query points sampled uniformly from the 3D scene, which can make these predictions far away from the real objects given the sparse object surfaces, resulting in slow convergence to capture discriminative object features with further misdetections. To accurately localize objects in a cluttered 3D scene, we reformulate the object queries in 3DETR into a conversion of the reference point position and the query embedding. Specifically, the vote queries learn to shift seed points that are uniformly distributed in a 3D scene to probable locations of objects and extract features from its local contexts. 3D dance captioning requires attribute details on an object and its relation with its close surroundings. However, the vote query itself is agnostic to box predictions and fails to provide adequate attribute and spatial relations for informative caption generation. The main difficulty is how to leverage sufficient contextual information without confusing the caption head. Thus, we propose the dual clue captioner, which receives two streams of visual clues for caption generation. When generating a caption for a proposal, we substitute the standard start-of sequence prefix with the vote query feature to identify the object to be described following 3D SPS. Since the vote query is agnostic of actual neighbor proposals because of the parallel detection branch, we introduce the vote query's k-nearest local context tokens as its local surroundings to the generation process through cross-attention. Since different supervision on the caption heads leads to huge difference in captioning performance, we make separate comparisons for MLE training and self-critical sequence training. Experiments on two widely used benchmarks, ScanRefer and NR3D, show that our proposed Vote2Cap DETR outperforms previous two-stage methods by a large margin. And it's also worth mentioning that our proposed method ranks first on the ScanRefer online test benchmark. We conduct studies on components of our proposed Vote2Cap DETR. As few works directly improve 3DETR, we compare our method with the hybrid matching proposed by HDETR and the learnable anchor queries proposed by anchor DETR. Results show that both methods are inferior to our method. Further, we find that though hybrid matching accelerates the training of 3D DETR in the early training epochs, it still falls behind our approach when the model converges. Besides, we provide a comparison on different keys used in caption generation in the table below. Introducing contextual information leads to more informative captions generated. Since 3D dense captioning is more object-centric, introducing Vote query's local contextual feature is a better choice. We compare qualitative results with two state-of-the-art detect then describe methods, 3DJCG and SwayCat 3D. We underline phrases describing spatial locations and mark correct attribute words in green and wrong descriptions in red. Our Vote2Cap DETR produce tight bounding boxes close to the ground truth and accurate descriptions. We visualize the absolute position of different object queries. PSEED used in 3D DETR is marked in blue, and PVQ used in our proposed Vote2Cap DETR is marked in red. Most of the Vote queries focus on objects in a 3D scene, as red arrows pointed out, while PSEED is mostly distributed in background areas, as blue arrows pointed out. We also visualize detection results of VoteNet, 3D DETR, and our proposed Vote2Cap DETR. Our proposed Vote2Cap DETR is able to generate accurate localization results. To conclude, in this paper, we introduce a novel one-stage framework to 3D dense captioning. We show that by reformulating the object queries into query position and query feature, and introducing spatial bias and content-aware features, Vote query boosts both convergence and detection performance. The novel lightweight caption head looks into both query feature and local context for informative and object-centric caption generation. Thanks for listening.